Okay, rational functions. Adding and subtracting rational expressions and solving rational equations. So for addition, it's just like if you're adding regular fractions, right? You need to make sure that you have a common denominator. So in order to get a common denominator, you're going to factor each of the denominators. Then you're going to multiply each fraction's numerator and denominator by the missing fraction. So you're basically just multiplying by 1. And then you'll add or subtract the tops like you're supposed to. And then factor and see if anything simplifies. So let's just jump right in. Example 1, they're already factored. So x plus 4 is already factored, and x minus 3 is already factored. So clearly the first fraction is missing in x minus 3. So I'm going to multiply the top and the bottom by x minus 3. And the second fraction is missing the x plus 4. So I'll multiply top and bottom by x plus 4. So you're just multiplying by 1. Now, you want to actually distribute on top. So 5x minus 15. Keep whatever symbol is in the middle of the problem and distribute on top. X squared plus 4x. On the bottom, just leave it factored. It's x minus 3 times x plus 4. Okay, now combine like terms or simplify the top. Then you want to check and see if the numerator is factorable. It would have to multiply to be negative 15 and add to be 9. I can't think of any numbers that do that. So this is where it ends, and then I put my restrictions. X cannot equal, the bottom can't equal 0, right? So x cannot equal 3, and x cannot equal negative 4, because the bottom can't equal 0. This would be my answer. Okay, let's look at the next example. It's got a little more going on, right? So, factor the denominator. There was a video on factoring earlier. You're going to need to practice your factoring on your own. I can factor in my head. If you can't, pause the video, make an area diagram, and factor that before I do. Minus 3 plus 2. And then this side is a difference of squares. All that factoring is going to be super important this chapter. Okay, so I've got an x minus 3, an x plus 2, another x plus 2, and an x minus 2. You don't need to have the same factor twice. So the x plus 2's are done. There's one on each side. I'm good. But the left one is missing x minus 2. So I'll multiply top and bottom by x minus 2. And the right side is missing x minus 3. So I'll multiply top and bottom by x minus 3. Remember, you actually do the multiplying on top, distribute. And then this problem is minus. We need to put whatever we get now in parentheses. We could have done it up above, but it wouldn't have mattered because plus doesn't matter. Always keep an eye out for those minuses, super important. When you multiply, you get 2x minus 6. I'm keeping my denominator in factored form. An x plus 2, an x minus 2, and an x minus 3. It doesn't need to be in any particular order. Now distribute your negative. Comes plus 6. Keep your denominator. Simplify the numerator. Keep your denominator. When you are showing your work, do not stop writing this denominator. You need to write it every single time. Now check and see if the numerator is factorable. So it needs to multiply to be 6 and add to be negative 4. 2 and 3 doesn't work. 6 and 1 doesn't work. So nothing factors. But my x cannot equal, based on my denominator, negative 2, 2, or 3. This is my solution. Okay, let's see what happens on the next one. Pause the video. Practice your factoring. Factor both denominators. If you don't pause your video, you're just going to see me do it, and that's not going to help you. See if you can figure out what each fraction is missing and multiply top and bottom by what's missing. So plus 2 is on both of them already. This is missing x plus 3 on top and bottom. This is missing x minus 2 on top and bottom. Distribute. It's plus, so I don't need to be as careful. And now you've got a little multiplying problem. Do an area diagram or FOIL. Multiply out 2x plus 1 times x minus 2. All over your common denominator. Simplify the top. Check and see if you can factor the top. I can't. Include my restrictions based on zero product property with the denominator. This is my answer. Okay, I need to show you what would happen. So let's say we did a whole problem and my answer came out to be x squared minus 4 over, and my denominator is always in factored form, right? Say you got here. So this step, let's just say our answer is this. This top of my orange example is factorable. So far all the ones we've done haven't been factorable. If it is, you need to factor it. And then you cross out matching factors, right? Because x plus 2 over x plus 2 is just 1. And my answer is x minus 2 over x plus 1. But in my domain restriction, it can't equal the negative 2 or the negative 1. Even though I crossed it out, my denominator still can't equal 0 ever in the problem. So the negative 2 is still part of my restriction, but it crossed out as far as my x's go. Also in my last example here, these x's do not cross out. You cannot just cross out one piece of an expression. That plus or that minus sign is holding that together. Think of it as having imaginary parentheses around it. Unless they completely match, you cannot cross them out. Okay, solving rational equations. Factor all the denominators, multiply each term by the common denominator, solve for x, and then check for extraneous. Okay, in our first example, they're already factored. My common denominator is going to be 3x, basically one of every factor, right? Just like when they were in parentheses. So I am going to multiply everybody on top by 3x. I like to do this in red. Usually in class I do this in red, so I'm switching over to red. Common denominator is 3x. Now it's in red. Okay, so when you go to do that, don't actually do it. Anything on top can cancel out with anything on the bottom, can reduce, I should say. So this x on top that we just wrote down crosses out with this x on the bottom, and now I'm left with 3 times 2, which is 6. Problem says plus. This 3 and this 3 cross out. Now I'm left with x times x, which is x squared. Problem says equals. 3 crosses out with 3. 5 times x is 5x. Now you've got an equation. It's a quadratic. Move the 5x to the other side, rearrange things. But you've got an equation with no fractions. You should be able to solve this. The only part I'm teaching you is the fraction part. You have quadratic formula or factoring in zero product property. This is factorable. It needs to multiply to be positive 6, but add to be negative 5. So negative 2 and negative 3. Practice your factoring. Zero product property gives me 2 and 3 as potential answers. But because this was a fraction problem, we need to go back and we need to check our answers in the original equation. So I'm going to check. Remember my equation was 2 over x plus x over 3 equals 5 over 3. Let's check x equals 2. So 2 over 2 plus 2 over 3 equals 5 over 3. So this is, well, I guess we can make a common denominator, right? Times 3, 6 over 6 equals times 2, not equals, plus, times 2, 4 over 6 equals 5 over 3. This is 10 over 6. And if you reduce that, you do get 5 over 3, so that's good. Now we need to check x equals 3. Pause the video and check x equals 3. I'm running out of space. That one works also. Both of these are my answers, but we always need to check because sometimes one of them doesn't work and you would cross that answer out. Okay, let's look at the next one. This one needs to be factored first. So clearly this is already in factor form. That's already a factor. This one needs to be factored. Hopefully you're practicing your factoring. So -1 and -2, x minus 1 and x minus 2. So I need to multiply everybody by that common denominator. Common denominator, x minus 1 and x minus 2. I'm only multiplying the tops because it's an equation. So I'm multiplying everything by that common denominator. X minus 1, x minus 2. X minus 1, x minus 2. X minus 1, x minus 2. But again, I don't want to actually multiply yet. I want to simplify. -1 and -1 cross out, and I need to multiply what's left. -2 and -2 cross out. There's a negative sign there, and I need to multiply by what's left. Problem says equals. They both cross out, and you just have a normal equation with no fractions. Move it all to one side, add, and it would go away. Well, I'll do it this way, sorry. Then move it all to one side. See if it's factorable. If it's not factorable, you have to do quadratic formula. Clearly we get an imaginary number. For this situation, that means there is no solution. But hopefully you understood how I got to the final equation. How about with a pencil right here? And then if it was factorable or solvable, you could solve it. Expect it to work out on test day. But this one came out to be no solution. Okay, one more. Pause the video, see what you can do. I'm going to start factoring. Even if you're not great at factoring, I mean, look at what the factors on the other side were. Chances are that's the factors on this side. So that's the common. I'm going to multiply everybody by that one. On top. Whatever I do to one side of an equation, I have to do it, to the other. Then start crossing things out and multiply what's left. Area diagram if you need to. Cross it out. Multiply what's left. The problem says plus. And cross it out. Write down what's left. Let's simplify the left side first. And then I like to keep my x squared positive, so let's move everybody to that side. See what we get when we're done. What is this? -8. Okay, again, if you haven't yet, pause the video and see if you can finish. Multiplies to be -8, adds to be -2, -4 and +2. Double check me. Zero product property, 4 and -2. And then check it in the equation. I'm writing kind of big. Let's see if I have enough room to do my checks. Let's do 4. Sorry. Actually, let me just show you the shortcut. The issue with this is that it was a fraction and you're not allowed to divide by 0. Do either of these numbers make you divide by 0? Yeah, right here. X plus 2, if I plug in -2, it's going to give me 0 in the denominator, and that's not okay. So that's not an answer, and the only answer is 4. So we got to one finally where there was an extraneous solution, and we found it by checking it in the denominators. Your denominator can never zero out, is what I call it. So if it's going to force you to zero out, it is not a solution. Hope you guys are doing well.